Hello, everyone. We'll get started in just a couple minutes. All right, let's go ahead and get started. Welcome to our webinar today, everyone. My name is Justin. I'm a quantitative specialist here at Statistic Solutions. During our webinar today, we are going to discuss the construction of quantitative research questions and hypotheses. If you have any questions, you can type those into the chat box. And at the end of the webinar, I will be doing a Q&A session. We'll also be sending everyone a copy of the webinar, as well as a copy of the PowerPoint. So let's dive in. I'll start out by giving a brief overview of the services that our company Statistic Solutions provides. Then we'll discuss research questions, how to formulate them, what types of designs apply to certain research questions. Then we'll conclude with a summary and a question and answer session. Our company, Statistic Solutions, provides assistance with every part of the dissertation journey. So no matter where you are, if you've hit a roadblock, please give us a call at 727-442-4290 for a free consultation. The way our company works is we assign both quantitative and qualitative methodologists to your project, as well as a literature review specialist. And we can help with topic development, finding a gap in the literature. We help with prospectus and concept papers, depending on what school you go to. Proposal chapters usually involve the introduction, literature review, and methodology. So within these sections, we can help develop your research design, your instrumentation. We can help validate your instrumentation, find support online to use a particular survey. We can help determine your data analysis plan. So what are the best statistical analyses to address your research questions? Then we assist with IRB forms, data entry templates. We can host a survey for you on SurveyMonkey. And then we can help with the results chapter. Once you've collected your data, whether it's archival or survey data, we can run the numbers, we can crunch them in SPSS. We have our own statistical software called Intellectus as well, which generates an APA write-up for you automatically. Then we can help with the discussion and PowerPoints for both proposal and final defenses. And once you graduate and you've defended, maybe you want to condense your dissertation into a journal publication. We can assist with that process as well. My colleague Brittany is also here, and if you have any questions about the services that we provide, you can message in the chat box or the Q&A box. Okay, on this slide, I have a couple hyperlinks to view the past webinars we've done. and the future webinars we will be conducting. Before we jump into research questions, it's important to lay the foundation for quantitative and qualitative research. Quantitative research usually involves the collection of data that's numeric. Okay, so anything that can be put into a number or numerical format, usually close-ended responses, whereas qualitative data usually involves open-ended responses. You would have to interview participants to uncover an underlying theme or meaning for what they are trying to examine. Before you develop your research questions, you first have to identify the research problem. What is the gap in the literature? And a review of the literature needs to be one of the first things that you establish before diving into research questions and problem statements and purpose statements. There are many ways. This is usually one of the big hurdles for students, I would say, is trying to find a unique study or trying to develop a unique topic. One suggestion I see to kind of get around this is by replicating studies that have been done in the past, but it localize the problem to a particular part of where you live, or in the US. Maybe the prior research was done collectively, in a large population setting. But if you take what a previous study has done and you narrow the focus to a particular location or population, it's replicating, but then you're adding your own spin to the topic. That is one way to do it. Another way is looking at different articles that you're interested in. And usually at the end of the article, there will be a recommendation for future research section. And using that information, you can develop your own study. And that will usually be, that will suffice for the gap in the literature, okay? Then you want to pinpoint the variables of interest. Okay, so after identifying the research problem, you identified a gap in the literature, you want to identify all the variables of interest that are going to be part of your research questions. You need to identify if they're numerically measurable, and are you planning to use a self-report survey, or do you plan to use archival data to measure these constraints? All quantitative variables fall into three categories for the most part. You can have nominal variables, which are things like gender, ethnicity, education. And then you have continuous variables, which are variables that fall on a scale or a continuum. Things like BMI, weight, height, composite scores from a survey. And then the final example is ordinal. You can have an ordinal variable, which is something that falls on a nominal scale, but it goes up a ladder, like a Likert scale: strongly agree, neutral, disagree, strongly disagree, something like that. That is ordinal. Okay. On this slide, we have the four most common quantitative designs. We have descriptive exploratory designs, we have correlational designs, we have experimental, quasi-experimental, and causal comparative. These kind of all fall into the same family, and we have longitudinal. So depending on what research design you select, you can formulate your research questions accordingly. And based on the research design, you can then figure out what's the best analysis to address those questions. So we will start out with the descriptive exploratory design. And when you do a descriptive or exploratory design, the goal is not necessarily to prove or disprove hypotheses. The goal is to describe trends that are occurring among the sample. The sample research question for this will look like this: what are the trends in job satisfaction among teaching faculty? or what is the most predominant leadership style used among managers. Notice that we're not connecting two variables of interest. We're not looking for differences by variables. We're not looking at predicting outcomes. We're just looking at general trends. And to address these questions statistically, you usually can use frequencies and percentages or means and standard deviations. These are called descriptive statistics. Okay, so descriptive statistics aligns with a descriptive or exploratory design. The limitation of this is that it may be too simplistic for most committees and most schools. I have seen some papers where the committee is okay with an exploratory design. However, many universities want something a little more rigorous that requires correlations or t-tests or NOVAs, something like that. But it doesn't hurt to try. You know, it can expedite the process if you can simplify the approach. The next research design is a correlational design. So correlational research is an umbrella concept that encompasses two types of analyses. It can encompass correlational analyses and it can encompass regression analyses. Correlational analyses are looking at two-way associations. Therefore, you don't need an independent or dependent variable. You just need two variables of interest. So a sample research question for this would be, is there a significant relationship or association between X and Y? It could be inverted as well. You know, when you do correlational or predictive designs, usually the independent variable will be first and the dependent will be second. But when you do a correlational design specifically or correlational analysis, you can invert this. So it could be, is there a significant relationship between Y and X? So some sample questions here with actual variables. Is there a significant relationship between age and self-efficacy? Some committees don't like having a yes or no type of response as we do here. Is there a significant relationship? Either you prove that to be yes or no, right? So the alternative phrasing to this is to put, to what extent is there a significant relationship between age and self-efficacy? Now it's no longer a yes or no response. It's kind of exploring the degree or the strength of the relationship, as opposed to just saying, yes, there is a relationship or no, there's not. Sample question 2, is there a significant association between education and job position? Very similar idea. Now, the analyses that can be used to address these questions are all correlations. You can run a Pearson correlation if you have two continuous variables. So a few slides ago, I mentioned level of measurement. You can have continuous, you can have nominal, and you can have ordinal variables. So you need two continuous variables to run a Pearson correlation. To run a Spearman correlation, you need to have at least one ordinal item. So a multiple choice item would suffice there. And then you can run a chi-square test of independence if you're looking at the relationship between two categorical or nominal constructs. So something like if you're testing the relationship between gender and passing and failing of an exam, gender could be male, female, and passing an exam could be yes or no. So you have two categorical factors. You could use a chi-square test right here. And here are the sample hypotheses. So hypotheses are really kind of simple to set up. You have a null hypothesis and you have an alternative hypothesis. The null is signified with a 0 next to the H, and then an alternative has an A. You're taking your research question and rephrasing it to be a statement. And, and usually we're trying to disprove the null hypothesis. We want to have statistical evidence to reject our null, which in turn means we are supporting the alternative. The null is always that there is not a significant relationship, whereas the alternative is that there is a significant relationship. And this logic will apply into the next research designs as well. No matter what analysis you use, this is kind of how the null and alternative are set up. On this slide, we talk about the regression approach. Okay, so we talked about how a correlational design is an umbrella that goes into correlational analyses and regression analyses. Here, we are going to look at regression. And when you see the word regression, usually that implies prediction. You're trying to predict a dependent variable. When you do a regression, you do need to have an independent variable, which is called the predictor. And you can have multiple. You can have multiple independent variables. And your dependent variable is called a criterion variable. Okay, and here we have the sample research questions. Is there a significant predictive relationship between X and Y? It could also be, to what extent is there a significant predictive relationship between X and Y? And then we have some sample variables in here. So just to illustrate, you can have one predictor, as we do in sample question 1, but you can also add multiple predictors. You could put gender, age, ethnicity. You can have any number of predictors, but you need to have one outcome variable. Sample question 3, is there a significant predictive relationship between GPA and passing and failing of an exam? So each of these questions are kind of unique. They would use a different analysis. For the first one, we would use a linear regression if self-efficacy is continuous. So you'll see down here, a linear regression needs a continuous dependent variable, whereas a binary logistic regression needs a dependent variable with only 2 possibilities, such as passing and failing an exam. So RQ1 would use a linear regression. RQ3 would use a binary logistic regression. A multinomial logistic regression is taking that binary idea, but extending it to possibilities that exceed 2. So you can have more than 2 groups for your dependent variable. So if you're trying to predict ethnicity, just to illustrate, if ethnicity was your outcome, you can have white, Black, Asian, Hispanic, other. You have more than 2 groups, that's when you can use a multinomial logistic regression. An ordinal logistic regression is used when you're trying to predict an ordinal outcome. Okay, so something like a Likert scale, if you're trying to predict one single item on a Likert scale from strongly agree down to strongly disagree, that's when you use a ordinal logistic regression. Here we have the sample hypotheses again, very similar to the previous example. We have the null and alternative. The next research design is experimental, quasi-experimental, causal comparative. These all go into the same family because the goal is usually to test for differences. That's the key word, differences in variables between groups. And this differs from a correlation or a regression because previously we're trying to predict. Now we're looking at differences. And to look at differences, you need to have an independent variable that is partitioned into groups. And then you need a dependent variable, which is the value you want to look for differences between. So an experimental-based question usually has the following format. Is there a significant difference in Y, your dependent variable, between the groups of X, your independent variable? Here we have some examples. Is there a significant difference in job satisfaction between treatment and control? Is there a significant difference in self-efficacy based on race? Taking this idea and compounding it by adding more dependent variables, you can look at multiple factors at once. So is there a significant difference in emotional exhaustion, depersonalization, and personal accomplishment based on race? And then you can even control for variables, which just means holding it constant in the model. So you can add control factors as well. Now for sample question 1, we have a continuous dependent variable, and we have 2 groups. That's when you run an independent sample t-test. For an ANOVA, you need to have at least 3 groups to compare. So it's similar to a t-test, but you have at least 3 groups as opposed to 2. So if race was your independent variable or education, that would be a situation to use an ANOVA. If you have multiple dependent variables, as we do here, we have 3 dependent variables, 3 measures of burnout. You can use a MANOVA, which stands for a multivariate analysis of variance. And then we have the control aspect, where you control for a factor. And this is where you use an ANCOVA or a MANCOVA. So that's an analysis of covariance. Here we have the sample questions. So we have kind of a simplistic example here. Is there a significant difference in job satisfaction between treatment and control? The null is that there's not a difference between the groups, and the alternative is that there is. Sample question 2 is a little more complicated because you have 3 dependent variables, right? So you need to have a separate hypothesis for each of them. We do 1 hypothesis for each burnout factor. The final design type is longitudinal, and longitudinal designs can have overlap with experimental designs. Essentially, if you're measuring data over a period of time, that's when you're doing longitudinal designs. So if you have a pre-test, post-test, or pre-test, post-test follow-up, that's when you do longitudinal designs. The reason this can have an overlap with experimental designs is that you can be doing an experiment where you have treatment and control groups, and you assign a baseline measurement, which is your pre-test. Then you conduct your intervention, and then you have a post-test measurement. So the treatment group will have a pre-test, post-test, and then the control group will have a pre-test, post-test. You have 4 moving parts there. That's where you do experimental and longitudinal designs simultaneously. So you can have simple pre-post without groups. That's sample question 1 here. Is there a significant difference in knowledge between pre-test and post-test? You can also add more time points. So it's not just pre and post, but you could have baseline, post-test, and follow-up. And then you can look at difference simultaneously between time, maybe pre-test, post-test, and groups, treatment and control. So for sample question 1, we would run a dependent sample t-test because we are looking at differences in a continuous variable between 2 points in time. A repeated measures ANOVA would be used to test sample question 2 because we have at least 3 points in time. And then a mixed model ANOVA would be used to address this last question because we have differences over time and we have differences between groups. Here are the sample questions. The first question is very straightforward for the hypotheses. You either do have a significant difference or you do not. Sample question 2 is a different approach as we have 3 parts. We have differences over time. We have differences by group. And usually when you are looking at time and group, you can also look at the interaction effect. So how do differences vary over time and by group, right? So I explained how you have pre-test control, pre-test intervention, post-test control, post-test intervention. That is the purpose of this third hypothesis, is you're trying to see differences over time and by group simultaneously. So in summary, the first step before you even get to research questions should be identifying the problem statement and the gap in the literature. You want to pinpoint the research design. Are you using quantitative versus qualitative? I should say research method. The method is either quantitative or qualitative. It could also be mixed methods as well. Then you want to identify the variables of interest. Do you have nominal, ordinal, or interval continuous variables? Determine whether you're going to use a survey or archival data to collect your data. I would definitely recommend a previously validated survey if possible. You don't want to develop your own survey because it's going to add a lot of time to the process because you have to validate it. You have to put it through a pilot test and ensure that the questions are reading properly, they can be interpreted properly. And then you have to establish that it's a reliable tool and a valid tool. This can add several months to the process. So I would highly recommend using a previously validated survey or use archival data. Then you can select your research design. We talked about the exploratory, correlational. You have the difference designs, which are experimental, quasi, and causal comparative. And then differences over time are longitudinal. Then you can develop your research questions and hypotheses and identify the statistical analyses to address those questions. So if you have any questions about the services we can provide, you can give us a call at 727-442-4290. We'll now do a Q&A session. If you have any questions, you can type those into the chat box. We have a question from Jane. What is the difference between quantitative, causal comparative designs and comparative designs? I've seen them used interchangeably. Honestly, I haven't seen comparative designs on its own. I haven't seen that verbiage. I usually see the causal comparative used simultaneously. So I would probably just go in the causal comparative route. I think they are the same thing. Just reading the question, I think they're both looking at differences between groups. And usually causal comparative it's using groups that are predefined, something like gender or ethnicity. It's not being influenced by the researcher. Those are predefined characteristics. Usually that is what is used in a causal comparative design versus a true experimental design where you are randomly assigning people to treatment and control. Causal comparative has predefined characteristics that are usually used as the independent variables. We have a question from Rochelle. Can you explain multiple regression? Yeah, so let me go back to that slide. Okay, so multiple regression is used, again, when you're trying to predict an outcome. So you need to have, when you're doing a linear regression, so your question said multiple regression, but there are many types. You can have multiple linear regression. You can have multiple logistic regression. The type of regression is dependent on how your outcome is measured. So if you have a continuous measurement, then you use a linear regression. But if you have a categorical outcome, like passing and failing an exam, or if you're trying to predict job position, say, manager, executive, employee, something like that, then you would use a multinomial logistic regression. So it's really used when you have a series of independent variables and you're trying to predict the outcome. Okay. And we have, let me briefly show you Intellectus, our company website here. This is our company developed software, and this is used to clean data. As you can see here, you can clean data, you can restructure, you can create composite scores, you can remove outliers, you can develop plots. You can also run the analyses in here. So we did some t-tests, for example, and it gives you an APA interpretation automatically. It checks for assumptions. Here's a linear regression. So for a linear regression, it is going to check for the assumptions of normality. homoscedasticity and multicollinearity, and then it's going to tell you whether, in this case, anxiety and avoidance predict this outcome. Is a medical measurement for oxytocin, and in this case, it does not predict. So just to illustrate what a regression looks like, if you're more in the methodology phase, we have data analysis plans right here. And if you go to regressions and linear regression, it's going to give you a sample research question. So you can just substitute your independent variables and your dependent variable. And it also goes through what the regression is testing. What is the purpose of it? What does the regression equation look like? What are the assumptions that are checked? And then it also goes through the interpretation. How do you interpret a regression? Okay, so this is also pretty useful. We have a question that said, I'm planning to use surveys to collect data for my quantitative research. What recommendations do you have regarding the use of that instrument? Okay. So you need keywords, right? I'm assuming you have your topic in mind, maybe some literature as well, but Google is going to be your friend here. You have to look for previously validated surveys. So say we're looking for a job satisfaction tool, something like that. So if I put job satisfaction survey and then put NCBI after it, and then reliability validity. NCBI is a database that has research articles, and this is a really good way to find previously validated tools. Reliability and validity are important, but in the Google search as well, because usually in the methodology chapter, you have to provide reliability and validity statistics. So if we just go on this page, we can take a look at this example. If you're lucky, if you go to the very bottom, you'll see the entire survey. Not always, so it looks like some of the questions are here. Yeah, many times you will see in the appendix the full survey. At that point, you may want to reach out to the authors. You'll see the authors listed at the top here. You may want to email them or find them on LinkedIn and see if it's a public survey to use. If not, you can ask for permission to use it. And once they give you permission, usually that response needs to go in your appendix as well. Okay, so this is the go-to method I use for looking for instruments. We have a question from Jane. Do you need a questionnaire or survey for archival project data? No, not necessarily. The whole purpose of archival or secondary data is that the data have already been collected. So it's on a database somewhere. And again, you may need to check for permission to use that data. But no, there's not a survey that needs to accompany the archival data. Usually the archival data is enough. Okay, so we have a question. Is the statistical analysis software like SPSS? Can we use your software to analyze our data? Yes, absolutely. Once you collect your data, you can upload it directly into Intellectus. And we can run all these different analyses. You know, we have correlations, we have descriptive statistics, we have assumption checking for normality, t-tests, ANOVAs, MANOVAs, regressions. I do see we had a question about the Hayes process. I'm kind of going to the next question here. So the Hayes process analysis for moderators and mediators. That's an extension for SPSS. Honestly, not something I'm incredibly familiar with. I have heard of it, but I don't have it on my SPSS. But yes, the Hayes process, I know that they give, let's see. I know there's a PDF form that's really useful for this. So they only have the download link right here, but there is a PDF that accompanies it that shows all the different models that you can make. You can have mediation, you can have moderation, you can have mediated moderation. There are 30 to 40 different types of models you can develop using that Hayes process. So I would check out their company website, which is right here. I'll put it in the chat box. Okay, we have a question from Rochelle. Do you have software to help with survey questions and demographic information? Do you mean developing survey questions? We don't have software for survey questions, but SurveyMonkey might be what you're looking for. SurveyMonkey or Qualtrics. Those are very popular websites used for collecting data. I think I'll need a little more information for what you're looking for. Yep, SurveyMonkey is great. Yeah, I use SurveyMonkey a lot with my clients. Between SurveyMonkey and Qualtrics, I think SurveyMonkey is cheaper. If you're trying to collect your own data, then I would say use SurveyMonkey. If you want to target a particular demographic, then both companies can be used. You can hire SurveyMonkey and Qualtrics to target people. Qualtrics is better in that regard, I would say, because you can speak to someone on the phone. They have great customer service. And the caveat to that is it's a little more expensive, Qualtrics. But yes, you can ask SurveyMonkey and Qualtrics to say, I want to target people with a master's degree in nursing that live in New York. You can target such a specific demographic, and they will generate survey responses for you. We have a question from Victoria. Do you have any written articles on this? I do not, but we have blogs. We have many blog topics. If you go to our company website, and you can check out the blog over here. And we have many different topics that we've covered, from quantitative methodology to literature to qualitative to interpretation of results, IRB, lots of different topics. You can also go to the webinars and the webinar archive. You can view our past webinars here. Okay, do we have any other questions? We had a question from MJ. Do you have recommendations for data collection? Personally, especially in the last couple of years with COVID-19, I would say I would have hired Qualtrics or SurveyMonkey to target participants for me. But as numbers are going down and life is slowly going back to normal, I guess, I've seen some students do a little bit better with collecting their own data. So the follow-up question is where to recruit for data collection for online surveys. I see a lot of students use LinkedIn and Facebook. There are groups that you can join that you can post your survey link, and if people meet the criteria for your survey, then they can complete the actual survey. They have to provide consent, and you can include questions on the survey to ensure they meet your inclusion criteria. And then if they do, they can complete the survey. But yes, I see LinkedIn and Facebook used quite a lot for recruitment. Okay, do we have any other questions? Looks like our next webinar will be tomorrow. My colleague Tom will be doing the topic on mastering the literature review. And then on Thursday, we're doing a quantitative results chapter webinar, which will be done by my colleague David. And then next week, I'll be doing this webinar next Tuesday, importing data to SPSS, data cleaning and management. And I'll also show a demonstration in Intellectus software. Thanks for joining, everyone. Thanks, Joseph. Thanks, MJ. Do we have any final questions? All right, excellent. Thanks for joining, everyone. Come join us for the future sessions and let us know if we can be of any assistance. Have a great day.